Greetings. Here we have a Bally power module board. This is out of an early Bally pinball. This particular board's probably circa 1980. And a viewer and frequent contributor, Dave O, sent me a bunch of these boards and told me that they were all not working. And I could do with them whatever I wanted, fix them, toss them, whatever. Of course, I'm not going to toss them. I'm going to try to fix them. And what I did was I fixed 4 of them. They're not very complicated. And maybe we should have a quick look at the schematics so we understand what this board does. So here's what the board looks like. Basically, this section here, all of this is the transformer. And it feeds into this board. Right here is the dividing line. And we can see there's 4 bridges on it. It turns the AC into DC. There is no voltage regulation, nor is there any smoothing capacitance on here. So it is called a rectifier board for short. And what else? Well, every leg is fused. Again, these are all DC voltages. This one here passes 6.5 volts AC straight through that are being used in the general illumination bus. Those are the lights that come on when you turn on the machine. They're always on. They're not CPU controlled or anything. So all this board does is, as the name suggests, is it rectifies electricity. So to have a look at this a little more in detail. So here's what comes from the transformer. Here are the fuses. There's 2 full wave bridges here made out of discrete diodes, 2 bleeder resistors, and on the back we can see 2 monolithic bridges here. They just have 4 diodes in there in bridge configuration, but it's all in a big heatsink case. These are rated at 35 amps. You can notice that there are burn marks on the board, specifically here, indicating that a lot of heat has passed through these boards. And that's because generally these boards were under-spec'd. I mean, they weren't made to last for the next 20 years. I think they were made to last until Bally released the next machine. And nowadays, these boards are 45 years old. They are, of course, they haven't been on 24/7 for 45 years, but in the beginning, these things were on for 24/7 and did a lot of heavy-duty work. Anyway, the boards I got, they're simple boards. The problems I found on the boards that I fixed were all identical. And oh, this is where the power is distributed to the rest of the machine as, as marked as back box, cabinet, and playfield. The problems I found on the other boards, the ones that I have fixed, were twofold. The main problem was that either one or both of these monolithic rectifiers were gone. Well, they weren't gone, but basically they lost one of the diodes in there would burn out, and that means they could only supply half the power that they normally would, or they would die completely. And another problem was that the clips for the fuses on all boards were severely corroded. And that's, again, not a big deal, except when the corrosion is between the actual fuse and the clip. because then it doesn't make a connection at all, which is okay because you can find that very quickly. What's worse is when it's just partially corroded, then you have, there's a resistance created in the path of this incoming voltage, and this board heats up. I mean, the fuse itself, this whole area heats up. But using a Dremel tool with a small brush, metal brush attachment to clean out the inner surfaces of these, fixed the boards that were suffering from problems. And I think all the boards, what the other boards also needed was they needed at least one of the rectifiers replaced. And all four of them came back. I didn't film it because it really wasn't a very complicated repair. You could pretty much just measure the bridge and then also see if there was continuity coming from, you know, going through the fuse clips, and that would immediately reveal what was wrong. The only other thing, again, that they're bleeder resistors here, and what they do is when you turn off power, I mean, even though there's no smoothing capacitors here, once this is hooked up, there are bigger smoothing capacitors on other PCBs, and the bleeders make sure that that voltage bleeds off, so you don't shock yourself when touching things inadvertently. However, there was one more board in there, and that board was specifically marked to be a parts board, and that's the one right here. And the most prominent reason why it was a parts board, aside from a lot of parts missing, of course, was over here something went really bad. This is the ground plane here that goes to the negative DC leg of this bridge, and it burned a hole through the phenolic material, and also the ground plane is supposed to be here, and all the metal is gone here. Again, it's probably not a big deal. The problem is when boards start carbonizing like this, the PCB material starts becoming conductive, and that can wreak all kinds of havoc. But there is some carbon between here and here, so it would need to be scraped. Do some scraping over here, but if it's all throughout the board, there's going to be conductivity between here and here, which isn't good. But what we're going to try to do is see if I can, you know, in my quest not to throw away things that could possibly be saved, I'm going to make an inventory of missing parts, do some measurement around here and some scraping to see is there actually conductivity between these pads or not. And if I have all the parts, basically stuff all of the missing parts back into it and see if it comes back to life. So let's go on inventory. Well, let's go and search, see if I can find the parts needed. Well, it looks like I found pretty much everything. Fuse clips over here, these missing connectors. I took these off other parts boards, which really were parts boards because they were cracked in half, or they really were not fixable, unlike this, which I still think it's going to work, but well, we'll see if my prediction comes true. So yeah, then we have two of the rectifiers over here. The only thing I had to do with the rectifiers, or fabricate, was if you look at the working board, you'll see that there's these square spacers between the board and the rectifier, and those were gone, of course. But what I did was, using some proto board without any traces on it, I just fabricated them with a Dremel cutting tool and a drill, and these should be fitting in here. If of course I thread in the leads properly. I think the leads got bent a little bit, but we can manhandle the insulator in place, and that's what it looks like. Same thing on the other side. So yeah, what we'll do is insert everything and solder it in place. Probably not going to film the soldering, maybe show you brief snippets of it. I of course also have to take care of this part, being very careful to connect whatever fits in here is connected to the ground plane securely, and I'm going to do some measurements here to see if there's any leakage between these planes over here and this carbonized part. And again, the part in the middle, it doesn't matter. It's the edges that you have to be careful with, because if there's too much carbon buildup, then that will create a path, a current path between the two pads. Okay, I did most of it. The only thing remaining are the big rectifiers. Now you want to use a fat tip. You don't really need to use, you don't need to use a 100-watt gun, but you do want to have a somewhat fat tip, and that'll work fine even on these thicker ones. And another thing is use some flux. I used flux not only for surface adhesion of the solder, but also so it goes through the hole and adheres on the backside of the board. Here I just took, with the missing metal, I just took the leg, bent it down, and soldered it straight to the ground plane. And with that said, we can now solder in, after pressing down on them, to make sure that they are flat. And yeah, the reason I don't do extended soldering on camera, it's a bit of a pain. And you've seen it before, right? And I'm probably obscuring stuff. But yeah, there you go. Flux really helps, even in situations like this. And I highly recommend you use flux in everything you solder. Come on. Almost done. I guess what remains is the fuses. I have to go make sure that I have all of the necessary fuses. Yeah, see, this one didn't get enough solder here because that pad is large. There you go. And for the last one, done. So here's where the board lives. This is the original board in the machine. I'm probably not going to remove the board, but rather pull all the connectors, put an insulating layer or something on top of it, and put our plug our freshly repaired board in. Now I'm tempted to just throw caution to the wind and say, let's just turn it on and see if the machine comes up, but No, I don't think so. I spent a lot of time getting this machine to work. So the first thing we'll do is we'll just plug in the transformer side, these two, and measure the test points on the board. Make sure that those are okay. Okay, time for the smoke test. And we will turn power on. No smoke. No apparently blown fuses or nothing else untoward seems to be happening. So let's actually check voltages, starting with test point 1. Shows 7.93 volts. That's good. Test point 2 is the high voltage, and it shows 187 volts. That's also good. Test point 3 is a bit high. Let's see, what's test point 3 supposed to be? It's the unregulated plus 5 volts. It's supposed to be 12 or 13 volts, but it is 19 volts. Unfortunately, that's a common occurrence on these machines. And the only downside is that the higher the unregulated voltage is, the more it'll heat up the regulator. But that's the way these guys are. So let's go to test point 5, which is solenoid voltage, and that should be and is 46 volts. And the last one, which is going to be AC, is test point 4. And that shows a lot of voltage. That one's not right. Oh no, there you go. I just had a bad connection. 7.37 volts. That's good. So we can now go to the next step. Plug in all of these connectors that go to the machine and see what happens. Okay, the rest of the plugs are plugged in. So now all of the smoothing capacitors, everything else is in the circuit, full load. And let's see what happens. 3, 2, 1, on. Oh, made a noise.
And 3 ball.
Oh. There's a ball that keeps falling back into a kick-out hole, but it seems to be working. Also looks like the displays are good. So all of the voltages are good. And that annoying solenoid kicking you heard obviously means that the solenoid voltage is good also. So, well, what's finally remaining? Let's see if it plays a game. All right, here we go.
Emulator functional.
displays also work. So it looks like our operation was successful. I'm gonna leave this thing on overnight and see if if it starts burning the board again or anything turns weird, but other than that, it looks like things are working. Thanks for watching. You may like and subscribe, and we shall see you next time.